Let's look at an example. So the first part is to find the derivatives of a function f of x equals x squared. So that means we want to find the derivative f prime of x, right? The second question is to find the tangent line at the point 1, 3 point, okay? So the first problem asks you to find the derivative, the slope of the tangent line at anywhere on the curve. The second question is actually ask you to find the tangent line for a specific point, 1, 3 point. Okay, so now let's look at the first part. To find the tangent and find the slope and the derivative of the function f(x) equals 3x squared, we just use a definition we just get, which is the limit of the difference quotient, right? This is f of x equals the limit h approaches 0 of f of x plus h minus f of x divided by h. You have to memorize this formula. Then we plug in everything, right? So here we have some students will make mistakes. So the denominator is still h, right? What is f of x plus h? So f of x equals 3x squared. So fx plus h, which is equal to 3 times x plus h squared. Okay. So we just replace the position of this x by x plus h. Okay, so it becomes 3 times x plus h squared minus f of x equals 3x squared. So the problem becomes how to evaluate this limit. So when we evaluate limit, the first step is we try to plug in 0, right? If you plug in 0, h approaches 0. Plug in 0 for h, you will have 0 over 0 form. We have seen this form many times. It's called undeterminate form. That means you need to modify this expression. So how to modify it? Let's square out. Okay? So it becomes 3x squared plus 2h times x plus h squared, right? This is the formula for the complete square, minus 3x squared. So let's distribute 3. It becomes 3x squared plus 6hx plus 3h squared minus 3x squared divided by h. So we notice that the 3x squared minus 3x squared will disappear. So you will have the limit h approaches 0 of h 6h times x plus 3h squared. So how to simplify it? So we divide h for each term, right? So it becomes, so we always have students make mistakes. They divide h for just for one term, then they say, okay, it's equal to 6hx divided by h equals 6x plus 3h squared. So this is wrong because you need to divide h for each term under the top, right? So this becomes 6x plus 3h. When you take the limit, now we can take the limit. H approaches 0. So this limit is not about x, it's about h, right? So x just a constant with respect to h. So if you plug in h equals 0, you will have 6x. So you can see that the derivative of f at x equals 6x, right? So for the different values of x, you will have the different derivatives. So this derivative is a function of x. It represents the slope of the tangent line at any position on the curve. So the second problem is ask you to find the tangent line at a specific point, which is 1, 3 point. So we can use this derivative. We know that f prime of x equals 6x. This is the derivative at any x. So now the point is 1, 3 point. So that means x equals 1, right? That means x equals 1. So we want to know, so the slope or at the point, the slope of the tangent line at the point 1, 3 point, which is the derivative of f when x equals 1. So if we plug in 1, so this is the 6 times 1, you replace x with 1, so you will have 6, right? So 6 is the slope of this tangent line at the point 1, 3 point. Then we can use what? We can use the point slope form to find the tangent line. So the tangent line, the equation of the tangent line is what? Point slope form. Okay, we use the point slope. We have the point, we have the slope, we have the point 1, 3. We have the slope 6, right? So it's equal to y minus y coordinate of this point 3 equals the slope, which is f prime at 1 times the parentheses. Inside is x minus the x coordinate of this point. So if you're not familiar with the equation for the straight line, you can go back to the pre-calculus to check the corresponding formulas. So this is called point slope form. Okay, so now let's plug in the numbers. Y minus 3 equals f prime of 1 equals 6, right? We just compute x minus 1 times x. So it's y minus 3 equals 6x minus 6. So y equals 6x minus 3. So this is called slope-intercept form, right? Okay, so which one is, all the forms here are correct. This one is okay for me, and this one is also okay for me. Okay, so it depends on the problem. Okay. So this is the one example. So now let's look at another example. If f of x equals 1 over x, so what is the derivative of this f at any point x? So we use the limit definition or limit process. With that h approaches 0, fx plus h minus f of x over h, right? So this would be the limit h approaches 0. So what is f of x plus h? So you replace the position of x with a x plus h, so it becomes 1 over x plus h. So fx plus h equals 1 over x plus h. Okay, you needed to replace the position of x, right? Replace the position of this box. So minus f of x equals 1 over x divided by h. Okay, so if you plug in h equals 0, plug in 0 for h, you will still have 0 over 0 form. So this is called undetermined form, so you need to modify. Right, so let's combine the numerator. The common denominator is for the numerator, which is x times x plus h, right? So the first fraction becomes x. The numerator for the first fraction is x minus the second one, which is x times x. We should have the same denominator, but the numerator becomes x plus h, right? So we do the subtraction over h. So it would be this would be the x plus h, right? This is the denominator. And x, then this would be x minus the whole thing, x plus h, so we use the parentheses. Then you will have the limit h approaches 0 of, so this is the h, this would be negative h, right, over x times x plus h. So we simplify a little bit. So this would be negative h over x times a. So you divide by h, which means multiply h on the denominator. So h and h cancel out, it becomes 1. So you will have the limit h approaches 0 of negative 1 over x times x plus h. So now let's look at if we can evaluate this limit. We try to plug in h equals 0. So you will have, yes, we can do that, right? Negative 1 over x squared. Okay, so that means for this function, the slope of the tangent line at anywhere on the curve is given by negative 1 over x squared. For the different x positions, x values, or different positions, you will have the different slope, right? For example, if you we want to know what is f prime of 2. F prime of 2, that means we want to know where is the slope of the tangent line at the point where x equals 2. So this would be, we plug in 2. So this is 2 squared, so this is negative 1 over 4. Right. Okay, so now let's look at a remark for the notations. So when we say f prime of a, that means we take the derivative of f of x, then evaluate x equals a. Okay, if we use different notations for the derivative, it would be df over dx, then we evaluate at x equals a. Right. Oh, you can see this one would be d over dx of f of x, then plug in x equals a. So from these notations, we notice that when we evaluate f prime of a, the first thing you need to do is you need to find the derivative at any point, right? Then the second step is you plug in x equals a to get your result. You cannot plug in x equals a first, then take the derivative.